Hi guys, today we'll be solving a very famous question, valid parentheses. I also have myself seen this question in a couple of interviews. So let's try and solve this question today. So we are given a string S that contains just the characters open bracket, close bracket, open curly brace, open square bracket and close square bracket. Determine if the input string is valid. The input string is valid if the open bracket must be closed by the same type of bracket. Open bracket must be closed in correct order. Every closed bracket has the corresponding open bracket of the same type. It means something like this: open bracket and a closed bracket, and we see these all brackets are closed by their respective closing brackets. And in this case, open bracket is closed by a closed square bracket, so that is a false. And then we are given constraints, so it will contain only these characters. Let's try and solve this. So whenever there's a question which involves that open bracket should be, or in general anything, that one event and later on the second event, one character later on second character has to occur, we should always try and think that if we can use stacks in that. In this case, maybe we can use with we can go ahead with stacks. So let's see an example. Let's take a input string. Let's try to solve it with using stacks. So what our approach will be, whenever we see an open bracket, we'll just blindly push it into the stack, and whenever we see a closed bracket, we'll be checking two conditions. We'll be checking if a corresponding open bracket exists immediately prior to it or not in the stack, and the second is if this if the stack is empty or not. If the stack is empty, it means that this closing bracket is just an extra bracket, so the entire string is just not valid. So this is our stack. So we are here. We'll push it in the stack. Then we come across this opening parentheses, we push it in the stack. Then we come across the closing parentheses. Whenever we see a closing parentheses, we have to check in the stack, is this the one that is corresponding closing? The top of the stack is the current corresponding closing bracket or the opening bracket. If yes, then we'll pop the top element of the stack, and then we'll immediately move to the next element. We see another opening bracket, so we'll just push it in the stack. Move ahead. Another opening bracket, we'll push it in the stack. Now we see a closing bracket. Is the corresponding opening bracket there in the top of the stack? Yes, so we'll pop it, and then we'll move ahead. We see a opening curly brace, we'll push it in the stack and we'll go ahead. A closing curly brace, do we have a opening curly brace in the top of the stack? Yes, so we'll move ahead. A closing square bracket, oh, we see that a opening square bracket already exists, so we'll pop this and we'll move ahead. A opening bracket, it exists, we move ahead. A corresponding closing bracket opening bracket exists, so we'll pop the top of the stack and then we'll move ahead. So we see a opening bracket, we push it in the stack. We see a closing bracket and a corresponding opening bracket exists in this stack, so we'll pop it out. So now we are here. We see a opening square bracket, we push it in the stack, and then we move ahead. So suppose if it was something like this, we move ahead, we see a closing bracket, the opening bracket exists, so we'll pop it off, and then we see a closing bracket, but the top of the stack is a opening brace, so it means that this string is not valid and we can return false. So I think you get the intuition. Let's try and look at the code. So as you can see, this is the C++ code. Let's try and discuss the code. So we use a standard library and we take a stack, and the stack is of characters because we are given a string and we'll be extracting individual characters from the string. So if we see an open bracket of any kind, we'll just push it in the stack. But if it's none of the opening brackets, then we'll go to the else part. If the stack is not empty, we'll go ahead, but if the stack is empty, we'll directly return false in the else part. But if the stack is not empty, we'll check if the top is corresponding opening bracket of the current elements bracket. If so, we'll pop it. It is same for all the three. And at the end, if the stack is not empty, suppose we have an element left at the end which is extra. Let's suppose this was this, and then we saw okay, top of the stack is this, so we popped it, and at the end there was an extra closing curly brace, so it would directly go to the else part and it will become false. If all of those cases are not true, eventually it will be just true and it will be returned. So this is the Java solution. It is the same as previous. You can take a look at it. If you did like the video, do share and subscribe.